Hello, everyone. I'm Everett Scaife, and I'm doing the Lesson 1 group problems here. Unfortunately, with my work schedule, I'm unable to meet up with anyone else, so I'm just going to do it by myself. Luckily, I'm able to do that. So, for the first question, we're supposed to perform the following cross between heterozygous A, heterozygous B, heterozygous C, homozygous dominant D, and heterozygous E with a heterozygous A, heterozygous B, heterozygous C, heterozygous D, and homozygous recessive E. And it says, A, what proportion of the offspring is expected to have heterozygous A, homozygous dominant B, homozygous recessive C, and homozygous dominant D, homozygous recessive E genotype. So what I went through and did was crossed each individual letter with itself, essentially. So rather than confuse myself, I just broke them up each into individual groups. And so for letter A, it's 1/2, 1/4, 1/4, 1/2, 1/2. And the odds of that exact genotype is 1 in 128. For B, it asks pretty much the same thing, just with the different probabilities or the different outcomes. And it should be 1/4, 1/4, 1/4, 1/2, 1/2. And the total odds of that is 1 in 256. And for C, it's homozygous dominant A, heterozygous B, homozygous recessive C, and D, and heterozygous E. And the odds of that happening, it's impossible. You can't get that cross. And for D, it should be for heterozygous A, heterozygous B, heterozygous C, heterozygous D, basically all of them heterozygous genotype. And the odds of that is 1, let me double check here. Yeah, 1/2 on each one of those. So when you multiply them together, it should be 1/32. For question 2, it's fill in the blanks. I found these answers from the notes and in the book. And it says a paired homologous chromosomes are sometimes called bivents or tetrads. The structure that connects the centromere to the microtubules of a meiotic spindle is called a kinetochore. A diploid fruit fly has 4 pairs of chromosomes. A fruit fly cell in prophase 1 has 16 sister chromatids, while a fruit fly cell in metaphase 2 has 8 sister chromatids. D, a test cross is a type of genetic cross that can determine if a purple flowered plant has the doubled or homozygous dominant or heterozygous genotype. E, a non-functional allele is sometimes called a null allele, while a partially functional allele is called a silent allele. Mendel's law of independent assortment involves 2 traits, while Mendel's law of segregation involves a single trait. Here's the last one there. Now for question 3, it says, suppose an organism has the genotype homozygous dominant T, heterozygous R, heterozygous Y, and we need to assume that each one of them assorts independently. So I diagrammed all the possible homologous chromosome arrangements in this organism due to metaphase 1, and I indicated each allele by just kind of drawing a line in between them for each pair of homologous chromosome. And I drew a picture here. It would take forever to try and explain. So hopefully that kind of, these lines up here. And then it says, indicate all the possible gamete genotypes that can be produced in this organism at the conclusion of meiosis 2. So gametes only have possible, or basically half of the chromosomes. So you have all dominant TRY and dominant, that's one gamete. Another gamete is dominant T and R with a recessive Y. Then we have the dominant T with the recessive R with a dominant Y. And the last one is a dominant T, recessive R, recessive Y. How many sister chromatids are found per cell in an organism during meiosis 1? I was going back through this one. I originally wrote 6 chromatids, but I found that it is actually, let's see, 12 sister chromatids. And D, I thought it was also 6 again, but it should be 3 chromosomes. So the question is, how many chromosomes are found per cell in this organism during metaphase 2, which is the gametes. For a horse has 32 pairs of chromosomes. Let's see. How many chromosomes are present per horse cell at the conclusion of meiosis 1? Let's see. Should be 32 chromosomes. How many tetrads are present per horse cell during prophase of meiosis? Should be again 32. How many sister chromatids are present in a horse cell during prophase of meiosis 1? Should be 64, I believe. How many sister chromatids are present per horse cell during metaphase 2 of meiosis? Should be 32. E, how many bivalents or bivalents are present per horse cell during anaphase 2 of meiosis? And I said 0 bivalents. And question 5, consider the following tetrahybrid cross in pea plants. Heterozygous TR, homozygous recessive Y, heterozygous A, with a cross of heterozygous T, heterozygous R, heterozygous Y with double recessive A. Assume that T is tall. The dominant T is tall. The recessive is a dwarf. The dominant R is round. The recessive is wrinkled. The dominant Y is yellow. The recessive is green. And the dominant A is axial. And the recessive A is terminal. And we're supposed to find the proportions. First one says, what proportion of offspring will be tall, round, green, and terminal? So after doing big old long cross and everything, I got 9/64 of the offspring will be tall, round, green, and terminal. In B, it says what proportion of the offspring plant has the double recessive T, homozygous or heterozygous R, heterozygous Y, and heterozygous A genotype. And that's 1/32 of the offspring. And C, what proportion of the offspring will be heterozygous for all 4 genes? It should be 1/16 should be heterozygous. And what proportion of the offspring will be dwarf, wrinkled, yellow, and axial? And I got 1/64 of the offspring will have those traits. Alrighty, well, thank you so much. That should be the conclusion of the homework. I hope I did it right. And yeah.